Hey viewers, you are welcome to my channel. Okay, in today's tutorial I want to as I promised in my last video when I was treating transcendental functions, I promised that my next video I will move on. So in today's video I want to treat the standard derivative and rules. Okay, all right. So if you are new to this channel, this is Mathematics Clinic by Tutor Chris, and make sure you just subscribe to my channel, turn on your notification so that whenever I upload a video you will be notified and you will have the chance to watch. Okay, all right, let's dive into today's course. Okay, now we'll be looking at the standard derivative and rules. Yeah, and these are the basics of calculus. Okay, the first thing I would like to show us, let me change my pen color, I'm sorry for that. Okay, I want to change it to black. All right, let's go on now. So the first thing I will let you know is that the limiting value, this is very essential. The limiting value of sine theta divided by theta, okay, as theta approaches zero. As theta approaches zero, is 1. Okay, so what am I trying to say? If you take the limit of sine theta over theta as theta approaches 0, if we take the limit as theta approaches 0, you are going to have 1. All right, this is a very beautiful concept which I would also like you guys to keep in mind, so that as we move on we understand what I'm talking about, because we'll be making use of this. It is very essential. All right, now the next thing I would like to let us know is that I will be treating the standard derivative. Okay, and when I'm talking about standard derivative, the first one I will look at is the trigonometric functions, that is the sine of x and the cos of x. Okay, and then the next one I will also like to dive in will be the exponential functions. Okay, that is the e of x. All right, okay, now let's move on. We move to standard derivatives. Okay, standard derivatives. Standard derivatives. All right, okay, don't forget that I said the first one I'll be looking at is the derivative of x, that is the sine of x. Now, so let me first look at the number 1, and these I'll be solving the derivative of derivative this should be a. Oh my god. Okay, derivative of a or y equals to sine x. All right, in this video, one of the happiest thing is that I will show you the origin, as I used to do in my videos, in my previous videos. So I will show you how we arrived at, you guys should have had that sine x. If you differentiate sine x, you are going to have cos x. Okay, but in this video I will show you why it is so. All right, now we are having the y equals to sine x. Okay, now I want to show you how we arrived at the differentiation, the derivative of sine x equals to cos x. Okay, all right, have your seat, feel relaxed and follow me. Okay, now so I'm having, don't forget, y equals to sine x. All right, now when we are talking about derivative, that is changing y over changing x, that's what I mean by derivative. Okay, now if you look at this function now, y equals to sine x, y is dependent on the value of x, that is y is a dependent variable, is a dependent variable. Oh my god. Now my viewers, what will be x? All right, our x will be independent variable. X is independent variable. All right, when I'm talking about dependent and independent variable, what do I even mean? All right, we are talking about dependent variable, that is the value of x here will determine what we are going to have for y. You can see that the value of y depends on what the value of x is. For example, if our x is 0, sine 0 is 0. Okay, if our x is 30, so we are going to have sine 30 here. And what's sine 30? Oh my god, sine 30, that's 1 over 2. Okay, don't forget, sine 30 is going to give us let's check. Sine 30 is going to give us root 1 over 2. And what's root 1? That's 1. We're having 1 over 2. So then sine 30 is going to give us 1 over 2. You can see y now will be 1 over 2 for sine 30. Y will be 0 when we're having sine 0. You can see the value of y depends solely on the value of x. Alright. So that's why I said y is a dependent variable and x is independent variable. Alright. Now let's move on. Okay, we're having y to be equals to sine x. Alright, now, and I want to add a little change to this x, that is, which is change in x. We call it a little change in x. Okay, and that shows that if there's a little change in x, there will also be a little change in y. Okay, why? Because we say that the value of y depends on x. Okay, that makes me to have y plus the y, which is change in y, okay, equals to sine over x plus change in x. Okay, because there's a change in x, as I said earlier, probably we are going to have a change in y because this value of y depends on the value of x here. I hope you get that scope. Alright, oh my god, keep on following, don't worry. Now we have in y plus the y equals to sine over x plus the x. Alright, what will be the next I'm going to do now? Okay, to show you how far this y has increased, the change in this y, now, I'm going to subtract y from both sides. That is, I'm going to have y plus dy minus y equals to sine of x plus dx minus y. Alright, that is, I subtract y from both sides. Now if I do that, y, which is positive y here, minus y is going to give us 0. So I'm having dy equals to sine over x plus dx, okay, minus y. Alright, this is beautiful. And don't forget our y is given to be sine x, so therefore I'm having my dy. Look at it very well. Our y is equals to sine x from the function. Okay, we're having dy equals to sine over x plus dx, okay, minus sine x, because that's the value of y here. Alright, so I'm having this now. Okay, now I'll be applying the trigonometric identity, okay, of half angle. Don't forget, if you're having something like this, trigonometric identity, let me write that. Trigonometry, okay, trigonometric identity now. Identity, okay. For trigonometric identity, if you're having sine over a minus b, okay, no sine of a minus b, this is same thing as sine a, because I don't want you to be confused when you see this in another textbook, sine a minus sine b. They are the same thing, because you open the brackets. Now we are going to have this. Okay, now this formula sine a minus b is equals to, okay, that's going to give us according to that trigonometric identity of half angle, I'm going to have 2 cos a plus b, okay, divided by 2, okay. Now sine a minus b divided by 2. Alright, so this is what I mean by the sine angle. This is what I mean by the sine angle, the half angle, okay, of this trigonometric identity. Now if sine a minus b is equals to 2 cos in bracket over a plus b over 2 sine a minus b over 2. Alright, you can see this is in form of this. This sine a minus sine b is in form of this sine over x plus dx minus sine x is form over sine a minus b. Okay, now alright, let's move on. Where, okay, our a is equals to, look at what we're having here. our A is what we have inside the bracket here, that is the value attached to this sign, which is x plus the x. My god, this is beautiful. And our B will be the value attached to sign here, which is equals to x. All right, since we know the value of A and B now, this is beautiful and we'll be able to move on. Okay, now don't forget, this is what we're having. We're having sine over x plus the x minus sine x. Okay, so of course don't forget, this is now the y now equals to 2 cos what's our A? Our A is x plus the x. Don't forget, this is our A, so I'm having x plus the x. My god. Okay, and what's my B? My B is x. Don't forget, this is my B plus x, all being divided by 2. Okay, all right. Now, and our sine now, we're having dot sine, which is multiplication of sine. Our A again is x plus the x, x plus the x, okay, minus B, which is x, okay, minus x, all divided by 2. All right, so this is what we're having for the value here. All right, now let's continue. We're having the y equals to 2 cos in bracket over x plus x, that's 2x, this plus this, that's 2x. So I'm gonna have 2x plus dx, okay, all divided by 2. All right, sine here again x minus x, that's 0, so I'm going to have the x over 2. Let me get what I just did here now, okay, because I've not done something tangible. This is just simple algebra. All right, now let's move on. So this means I'm having the y equals to 2 cos now this means that, you know, this is the LCM. If you divide 2x by 2, I'm going to have x plus, and then the x divided by 2. Okay, okay, that's good. Sine the x over 2. All right, this is beautiful now. Okay, I hope we understand this very well now. Okay, so because what I mean by derivative, don't forget, we want to find from the question here, we say that derivative of y equals to sine x. We want to find the derivative of y equals to sine x, and derivative means the change in y over change in x. So I'm going to divide both sides by dx because we are looking for the derivative. Okay, so I'm having this divided by x dx, and this divided by dx. Okay, I will get that now. So I'm having the y, oh my god, you just have to manage my line here. Okay, I'm using left hand, so sometimes it's difficult for me to have a straight line like this. Okay, just accept me like that. All right, I trust you. Now we're having this, but don't forget, this is same thing as this. If you apply the algebraic sense, this is same thing as cos of x plus dx over 2. Okay, dot 2 sine dx over 2. Okay, all divided by dx. Do you agree with me? You know, these two cos this sine this, you know, is multiplication, so I can even bring it here. If you still multiply, we are still going to have same thing. Okay, I hope you understand that now. So dy dx is equals to, all right, I want you guys to follow me, to have full attention. Okay, now I'm having cos over x plus dx over 2 dot 2 sine dx over 2 all over dx. Okay, now the next thing I can also show you is that, you know, this is multiplication, so that means I can also represent this as cos over x plus dx over 2. Okay, how we get this? This is cos of x plus dx over 2. Okay, dot 2 sine dx over 2. Okay, divided by dx. All right, you know, if we multiply this with this again, we are going to have this back, that is cos of x plus dx over 2 multiplied by 2 sine dx over 2 all over dx. If we multiply this now, you know, assuming this is over 1, you know, it's still same thing as cos of x plus dx over 2. So if I multiply this with this, I'm still going to have our denominator, and this will remain my denominator. I hope that's clear to you guys. All right, wonderful. That's very good now. Okay, I believe you guys have understand what I'm trying to say over there. Okay, now this is what I'm having. Now this can also be rewritten according to the law, to the sense of algebra, as cos over x plus dx over 2. Okay, dot. Now you know this is same thing as if I divide the numerator, that is I divide 2 sine dx over 2 divided by 2, okay, over dx divided by 2. That is I divide the numerator and the denominator by 2. All right, this is gonna give me don't forget to having the y dx at the left hand side, the y dx, all right, equals to cos over x plus dx over 2. Okay, dot. Now this 2 is going to cancel this, so I'll be left with sine over dx over 2. This is variable. Okay, so over this, over dx over 2. Oh my god, this is variable now. Oh my god, I don't know if you guys can notice what I'm seeing here. Can you notice what I noticed? Oh my god, that's wonderful. Don't forget, I already showed you that if you're having the sine over sine theta, that's where I used to start this tutorial. Okay, over theta, if you take the limit of this as theta, the limit of this as theta approaches 0, we are going to have this to be equals to 1. All right, so automatically, don't forget, this is dx over 2, dx over 2. So it's same thing. I will get what I'm trying to say now. If you take the limit of dx now, if you take the limit of the x with this, okay, as the x approaches 0, okay, this is what I'm talking about. Let's take the limit of the x as it approaches 0, okay. So that means this is going to give me 1 limit to us over dx as it approaches 0. Now this is going to give me, don't forget, this is cos. Without opening the bracket, I will still have my x, but dx now is 0 plus 0 over 2. You know, 0 over 2 is still 0 as it approaches 0. Okay, so I'm having 0. Oh my god, this wonderful dot. Don't forget, this is now as it approaches 0, we are going to have a sine 0 over 0, and that is going to give me 1. Okay, that's 1. I hope we get that. All right, now if you don't understand that, you can let me know in the comment section. Okay, all right, I'm having the y over the x, okay, to now be equals to, you know, I've taken the denominator already, so this is going to be cos multiplied by x multiplied by 0. So I'm going to have a cos of x plus, that is this multiplied by this, now this cos of 0, okay, plus 1. Okay, I get that now. And oh, sorry, there's a mistake. Sorry for that. I'm so sorry. There's a mistake. Sorry, I'm so sorry. I'm really sorry. I made a tangible mistake. Oh my god, I'm so sorry for that, my viewers. Okay, this is what I'm trying to say. This is x plus 0, x plus 0, and x plus 0 is going to give me x. No, 0 doesn't matter, so I'm having cos of x, okay, dot 1. All right, and if we multiply cos x by 1, we are still having our dy dx to be equals to cos of x. All right, so you can see this is the derivative of y equals to sine x. All right, if you like this kind of video, don't forget to subscribe to my channel, invite your friends to watch my video, turn on your notifications, so whenever I upload a video, you'll be notified and you'll be able to watch my video. Thank you. See you next time. Bye bye.